Now, this week we're going to be talking about, or this topic, we'll essentially be talking about workshop tools and measurements. What are some of the tools we use, hand tools we use in the workshop? What are some of the measuring instruments we encounter in the workshop? And we had talked about some of these as we were going through topic 2. We were mentioning them, we were seeing them in videos as they are being used. And this topic we are going to go into detail kidogo, and also the next topics. But this topic, workshop tools, we're just going to be tutakuwa tunaangalia sana sana the hand tools. Now, before I start on the tools, we are going to look at some of the terms that we encounter while dealing with measuring instruments. They are not only the hand tools. Any measuring system that you will find out there that we use to make measurements, there are some terms that we have to know that we'll encounter. Now, readability is the closeness with which the scale of the instrument can be read. What do I mean by this? If I have a ruler at 15 centimeters and I have a ruler at 30 centimeters, then the ruler at 30 centimeters will be easier to read as compared to that 15 centimeters. That is what I mean when I say readability. There are some instruments, come a rule, a meter rule or a ruler, that come at 30 centimeters, the graduations will be easier to read as compared to that of a 15 centimeter ruler. List count. This is the smallest measurement that a measuring instrument can read. For example, when you take your 15 centimeter ruler, from one point to the other, from one point to the other. For example, a ruler has zile distinctions ama zile calibration from zimekuwa calibrated in centimeters and millimeters. So from one division to the other, the smallest division hapo is a millimeter. So when I take one measurement from one division to the other in a ruler, hii ya kawaida tunatumia class, and that is the least count. It is the smallest difference between two indications in that ruler. So you'll find that the least counts in different measuring instruments are different. Kwa mfano, the least count in a micrometer will be different than that of a ruler because of the scale. The scale determines the least count. So, but when you take the value between the indications, two indications, then you'll be able to get the least count. Now, the range is the value represents the value that you can measure from the least to the maximum of that measuring instrument. When I take my ruler, the 30 centimeter ruler, my range will be from 0 to 30 centimeters. From the least value to the largest value that measuring instrument can read. That is what we call dynamic range, or range. Now, sensitivity, on the other hand, indicates how much input of an instrument or the measuring system changes when the quantity being measured changes by a given amount. Essentially, what I mean by this is it's the ratio of the output versus the ratio of the input. What I'm measuring, how much the measurement, the output from a measuring instrument changes when the quantity that I'm measuring changes. So it's the output versus over the input. Now, repeatability is when I take a measurement, when I'm measuring the same quantity repeatedly, more than one time, the ability of that instrument to get the values, the same value, when I'm measuring the same quantity over and over again, that is what I call repeatability. We do this so that we can be able to see how accurate our instrument is. For example, I'll be measuring pressure of 50 bars. I take that measurement once, twice, thrice, 4 times. So if my measuring system, my instrument is accurate, then I will get a value that is the same or close to the same. But there are some measuring instruments, when I measure the same quantity Kama ni pressure, if I measure 50 bars, then my indication ama my indicator, maybe the first time italeta maybe 30 bars, the next time italeta 60 bars, 40 bars. So you'll find that this instrument is not as accurate. So that term is known as repeatability. Accuracy. Accuracy is how close the measured value is to the true value. When we are talking about, let's say we are measuring the length of a metal, of a piece of metal, and the true value is 10 centimeters. Then I use, for example, a vernier caliper. The measuring instrument is a vernier caliper, and I find that my length is 10.3 centimeters. Then the closeness of that reading to the actual value is what we call accuracy. And then when we talk about accuracy, then we have to introduce the concept of errors. Because you're going to be taking the value that you've gotten from your instrument, whether it is more than the true value or less than the true value, and then you subtract it to the actual true value so that you can get the accuracy in terms of percentage. How accurate an instrument is determined by how close that measured value is to the true value. Precision now is how close those measurements are to each other. For example, when I measure a quantity, hata sio when I measure in a quantity, tuseme kama tunacheza dart, when I throw ile dart, how close those darts will be to each other is what will determine how precise I am. Kwa wale ambao wanafanyanga marksmanship, those guys who practice kama polisi, for you to be qualified as a good sniper, ama a good marksman, how close you shoot your groupings together is what determines how precise you are. Yeah, so the closeness of which, when you measure a quantity, how close these quantities are to each other is what we call precision. It is a limit within which a signal can be read. Now we have resolution. It specifies the smallest change in a physical property that causes a change in the measurement. Yeah? So the smallest change in my physical property, if I'm measuring temperature, the smallest change in temperature that will cause a change in the measuring instrument is what we call resolution. We have threshold. Now, if I increase the input, whatever I'm measuring, in a measuring instrument gradually from 0 up to a certain point, that input will reach a minimum level before the change in the instrument is registered, before there is an output that is large enough to be detected by the measuring instrument. Now that minimum value that the measuring instrument needs to read so that there is a change in the output is what we call threshold. Are we together up to that point?
Yes.
Now, response time. This indicates the time that it takes once I change the physical quantity that I'm measuring up to the point when it is registered as an output in the measuring instrument or the measuring system. This is what we call response time. You'll find that some instruments are quick to register that change, and there are some that have a lag time. Zina take time kabla hazija register the output. So the time that it takes, the time that elapses when there is a change in the physical quantity you're measuring, up to the point the instrument registers that change as an output, is what we call the response time. Now, tolerance. The best way I can explain tolerance is when you go buy a screw and a nut from different hardwares. Nienda ninunue nut hardware moja, ninunue screw hardware nyingine. And there are, let's say nimenunua 14 inches diameter for each. You'll find that even though I've bought them in different places, they'll fit. Reason being is that we have the aspect, we have the concept of tolerance when we machine these parts. Now, tolerance is usually defined as the maximum acceptable difference between the actual value and the value specified for it. It is that allowable amount which the measurement can vary. And that's why when you're making whatever you're making, there's always that, as a good engineer, as a good craftsman, if I'm going to be cutting a piece of metal, then I have to take into consideration that allowance. If I'm cutting 10 centimeters in my workpiece, nataka kukata chuma ya 10 centimeters, then I won't cut 10 centimeters exactly. I'll cut maybe 10.2, 10.3. I'll give myself that allowance so that in case there is any mishap when I'm cutting or when I'm machining them, I can be able to have some room to rectify my problem, the issue. Imagine when you cut 10 centimeters, that is what is required. But you make a mistake during the actual process, ukakata 9 centimeters. Then you don't have that room to make adjustments. So tolerance is what is defined as that allowable amount which a measurement can vary. Now it is usually the difference between the maximum and minimum limits, and we're going to see what limits mean in just a few seconds. Now, scales. We've all seen scales in measuring instruments, ama hata ile ya kupima kilo kwa hardware, kwa butchery. Now, scales can be linear or non-linear. Now, a linear scale is one whose divisions are equal to each other. They are proportionate. If I have a ruler, for example, the 30 centimeter ruler, you'll find that those divisions are equal. One division equal, which is equal to 0.1 of a centimeter. That is what we call a linear scale. The grids or the divisions or the markings are equal in value. But for a non-linear scale, there are some instruments that have a non-linear scale. The divisions of those markings are unequally spaced, meaning that these lines of markings are not equal or constant in value. So you'll find that some measuring instruments have a linear scale and some measuring systems or instruments have a non-linear scale. I'll send pictures of a linear scale and a non-linear scale so that you can see the difference. Now, when we talk about limits and fits, a good example is when you have a shaft and in this case, we have a shaft here, and then we have this hole. And I want to talk about fits first. Now, when we in engineering, basically, a fit will refer to the clearance between two mating parts. So lazima ikuwe a shaft, but any part that is mating then is usually referred to a fit. Now, this type of fit determines whether that part can move relative to the other, or it can ama itasonga. If it is able to move relative to the other, meaning that there is space between those two mating parts, then that type of fit is usually known as a clearance fit. If that fit ni tight, meaning that I cannot be able to move those two mating parts, that is what we call an interference fit. It is known as an interference fit. Now, for mating parts that iko katikati, fits that are in between that of a clearance and that of an interference are usually known as a transition fit. So it can fall in between. It can go towards that of the clearance, or it can go towards that of an interference fit. Now, when we talk about limit, the maximum, the extreme permissible sizes that a part can be made is usually known as the limit. And this is usually in any design. Let's say we want to design a rectangular box, and the length that you want, in our design, we want that length to be 10 centimeters. But we have to put that aspect of tolerance. So we say that our actual size 10 centimeters will be in between a plus or minus 1. So you find that the maximum permissible size is 11, and the minimum permissible size in this case is, let's say, minus 1 centimeters. So you find that those maximum extreme limit, permissible sizes that contain the actual size that we want is what we refer to as limits. Are we together? Tuko pamoja. So on this side, when we talk about upper limit, is that 11 centimeters. When we talk about lower limit, itakuwa ile -1 centimeters. Now, when we talk about fits, I will use these terminologies. I have written them in your notes. When we talk about lower deviation, upper deviation, maximum diameter, minimum diameter, I have written them on the notes ambazo nimetuma pale Google Classroom, so you can go read them and write them as well so that you can identify. But I will mention kidogo tu. Now, when we look at this shaft, kumbuka shaft is a solid material. So we have mahali ambapo, when I mean solid, kuna the inner part and the outer part. So the minimum diameter is between those two inner parts, hapa na hapa, and the maximum diameter is between those two outer parts. Now there is that part which is this line ambayo inakata through hii hapa. That is usually known as the zero line, ama the line of zero deviation, meaning that when we made a design, that was the actual size, the nominal size of our shaft that we wanted, ambayo haingeleta deviation. So when we take the upper part of the shaft and that line, what we get is the lower deviation, no, the upper deviation. When we take the inner part of the shaft and that zero line, what we get is the lower deviation. So you can go through those notes and so that you can familiarize yourself with these terms. For now, they're not important. What we wanted to talk about is tolerance, the ones that I've mentioned in the slides. But this is also important when we talk about fits, especially. Now, let me talk about fits kidogo, the clearance fit, and I'll use that example of a shaft and a hole. Now, if my shaft is larger, my hole, shimo yangu ni kubwa kuliko my shaft, that means that my shaft can move relative to that hole. There is space for that shaft to move. That is what we call a clearance fit. An interference fit is my shaft is bigger than the hole, so I'll have to apply some force to be able so that the shaft can enter that hole. We have to apply some force or some lubrication so that that shaft can be able to fit into that hole. Now that is what we call an interference fit. Now a transition fit is the shaft may be a bit bigger than the hole, requiring some force to fit. On the other hand, the hole might be a little bit bigger than the shaft, meaning that it is in between. The transition fit can be in between those two fits, but the major ones are the clearance fit and the interference fit. Now, let us talk about marking out, and that is the main subject of today's lesson. Those terminologies ambazo tumesema will be everywhere when we talk about measuring instruments, ama measuring system. Now, marking out. What is marking out? When I am transferring a piece of design onto a workpiece or onto a piece of metal, let me say a workpiece, onto a workpiece, kwa sababu inaweza kuwa ni mbao, it can be plastic. When I'm transferring a piece of design on the surface of that workpiece by either drawing lines, arcs, circles, that is what we call marking out. And there's specific ways of doing that, of marking out. But that process of transferring a design onto the surface of a workpiece by drawing lines, circles, or arcs is what we term marking out. Now, what are the purposes of marking out? The first one is to indicate the outline, the workpiece outline, or the position of slopes or holes. You're indicating the outline of that workpiece. Remember, sio kila workpiece ambayo itakuwa regular in shape. There are those ambazo zitakuwa na mabonde, kwa mfano castings. We have seen castings, and you have seen how irregular castings are in shape. So for me to indicate the outline or the position of various parts of that workpiece, that the purpose is that is one of the purposes of marking out. I can also draw lines on a workpiece or circles so that I can create a guide for me to be able to set that workpiece on the machine. And we will see how when you are looking at some of these tools that we use when marking out. Now, an important part in marking out is a datum. A datum is a very important term or part in marking out. Now, this is used as a reference point where we take our measurements, where we'll be measuring, where we'll be taking our dimensions. For example, this is my workpiece over here. It is irregular in shape. I can draw a line, or I can mark out a line, I'm ascribe a line there, and this will be my datum, so that when I'm making measurements and I take a ruler, this will be where I'll be taking the measurements. This is what we call a datum. Here, a datum is that place now, I'm at that position, I'm at that reference position where I'll be taking my measurements. Now, a datum can be a point or an edge or a center line. And in this case, let's look at this. We have a datum that is a point. So if I want to make measurements, for example, I want to make a measurement, a radial measurement. This is my, I want to make a measurement in terms of a radial measurement. Then I will have a datum as a point. Kwa mfano, if I'm drawing a circle or an arc, and I want to find out the radius of a particular position on my workpiece, that datum will be a point. This is an edge. If I'm taking a datum as this point, then this is an edge datum. If I'm taking a point datum as the center of this circle, then these center lines, these two center lines that are intersecting, are what will be the datum of this workpiece. And this is the datum is usually determined by the shape of the workpiece. Kama hii siwezi chukua the edge as the datum kwa sababu this side and this side, the length will differ. I mean, the distance between these 2 points will differ kwa sababu the distance up from that point to that point is different than the distance from that point to that point. So depending on the shape of the workpiece, then it will determine the type of datum that I'll use. Now, there's something I want to mention that I haven't indicated in that presentation. Coordinates. When coordinates are essentially what we use to refer to a specific point. Kama sasa ukienda kwa your internet and you type your coordinate, ama the coordinate of Mombasa, the coordinate of whatever, it will show you the actual point in terms of latitude and longitude. Now, since we don't have latitude and longitudes in our workpiece, then coordinates are what we use to determine the points. For example, if I was to take this point, how will I know the position of that point? I use coordinates. Now, coordinates can be of two types. We have Cartesian or rectangular coordinates, or we have polar coordinates. Rectangular or Cartesian coordinates are those coordinates or dimensions, are where dimensions are taken relative to the datum at right angles to each other. Kama hii hapa. If I want to find the coordinate of this point, I'll take the length from this datum, this edge, and then I'll take the measurement from this datum, these two, so that when I read this coordinate, itakuwa labda 20,14, meaning that the distance from this datum to this point is 14 centimeters, and maybe the dimensions, I mean the length from this datum to this point is 20. So when I'm asked the coordinate of this specific point, then I'm able to. Sana you won't be able, this you'll see it when you're doing drawing, AutoCAD or when you're using computer applications and you want to specify a specific point on your workpiece, or your drawing, then you use rectangular coordinates, where we take the dimensions relative to datums and they're at right angle to each other. Now, polar coordinates are where we take them, where dimensions are measured along a radial line from the datum. When we make sure coordinates along a radial line from the datum is what we call polar coordinates. For example, if I'm taking coordinates of this point on this circle, since this is not a rectangular workpiece, then this coordinate that I'll take along this circular point is known as a polar coordinate. Sawa. Kama tuko pamoja, please unmute and say that I'm present. Nisikuwa naongea peke yangu.
Present.
I've sent these notes in the Google Classroom, so you'll go through them, or you can even refer to them as we continue with this class. Now, what are some of the instruments or some of the equipment we use in marking out? Yeah? What will we use to draw lines or arcs or circles on our workpiece? The first one, and one of the most important, is a surface table, and is that diagram ambayo nimeonyesha hapa. Now, what do we use a surface table for? Now, if you look at this table, this surface is straight. Yani hii kitu imechongwa mpaka it is level throughout. It is the same height everywhere, that surface is just machined perfectly. Now, if for me to establish a datum from which I will take my dimensions, then I have to have a reference surface on my workpiece. Now, how will I establish this reference surface on my workpiece? I will place my workpiece on the surface table. Nitaekelea workpiece yangu juu ya hiyo meza. Then I will be able to see whether my workpiece is flat. Essentially, we want to test the trueness of the flat surface of my workpiece. So I will put my workpiece on that surface table, and then I will be able to mark it, to create a reference for which I will take my dimensions from that workpiece. Now, if I have a smaller workpiece, kama chuma yangu ni ndogo, ama plastic, then I use something known as a surface plate. This is just a smaller, not a replica, but we use this for smaller workpieces. Yeah? Then I will place my workpiece on this surface plate, and then I will be able to mark the reference point on which I want to take my dimensions. It will also be able to test the trueness of the flat surface of my workpiece. This surface is flat. Haina mabonde, it is purely flat. Now, these surface tables, some surface plates are usually made of cast iron. Sana. There are those that are made of graphite and other materials. Now, the surface table is usually coated with an oil for you to protect this surface, because this surface is very sensitive. You coat it with oil and then you cover it with a piece of metal ama mbao, a wooden cover. Hata ukienda kwa workshop, you might not see this surface. What you'll see is just a wooden covering, especially the table, this table over here. Utapata imefunikwa na mbao ama chuma, but this surface is usually coated with oil. Hopefully when we go back to school and time allows us, we'll be able to go to the workshop and also get the chance to interact with these tools. Now, there are other tools that are known as parallels. Now, if I want, for example, to create a datum for my workpiece, and I want to raise that workpiece a few inches or a few centimeters from my surface plate or my surface table, then I will put that workpiece on these two pieces of metal known as parallels. This usually raise it off the reference surface and still maintain that parallelism between the surface table and the workpiece. Remember, the surface table is flat, the parallels are also flat in nature. So if I put a workpiece on top of the parallels, then this surface table and this workpiece will still be parallel to each other. Now these parallels are usually made, they're similar in dimension. They usually come in pairs and they're similar in dimension, and they're usually made of hardened steel. So you can have parallels of different dimensions kutegemea na the size of the workpiece that you want to use, or the size of the workpiece that you want to mark out. Now we have these jacks and wedges. Now, if I have an irregular shaped workpiece, kwa mfano a casting ama a forge, and I want to mark it, the same way katika kama unafanya mfano repair ya gari, unaekanga a wedge between the tires so that the car doesn't move to and fro while you're doing your repairs. It's the same thing, the same concept. Nitaeka a wedge at a certain place, in between. I'll put a wedge at a certain location, ama the correct position, so that I can support my irregular shaped workpiece. Kwa mfano a casting ambayo iko na shape, a very what do I say, uneven surface. So you can prevent it from rocking to and fro, and keep it parallel to that surface, the meza, the surface table, by using a wedge, or I can use a jack, depending on how irregular the surface is. Now, this I think that's enough with that. Now, another tool that we find in the workpiece, in the workshop, that is used for marking is known as an angle plate. Now, what is an angle plate used for? If I want to position my workpiece 90 degrees to the reference surface, for example, I have a reference table over here. Ama meza tu. I have a reference table or a table or a surface plate. A surface table or a surface plate, and I want to position my workpiece 90 degrees. Siwezi ishikilia tu na mkono and I assume that workpiece will be 90 degrees. I can't just hold my workpiece and say that it is 90 degrees. So what we do is we use an angle plate, and we will put our workpiece side by side to that angle plate, so that it is 90 degrees to the surface, the reference surface here upper. So this angle plate has these slots. These slots will help us clamp. Itatusaidia kushikilia this workpiece using clamps, so that it is 90 degrees to this reference surface. Now, these angle plates are usually made from cast iron, and the faces, the edges and the faces of these are usually machined flat. They are square and they are parallel. Zinakwanga perfectly machined to be 90 degrees. Are we together? Tuko pamoja?
Yeah.
This is are you able to see these diagrams? Zinaonekana kweli? Najua mmenyamaza sana mpaka sijui kama mko na watu katika hii class. Now, this is a diagram of this. There is this sheet metal, and you want it 90 degrees to the reference table, and you want to make markings. Tunataka kuchora labda line on this surface plate, and I can't just hold this surface plate and assume that it will be 90 degrees to this reference table. So what this diagram shows is we are placing this workpiece, this sheet metal, on the face of the angle plate, and then I clamp it. In clamp, naishikilia na hii clamp, I clamp the workpiece against the angle plate, so that this workpiece will be 90 degrees to this reference table, this surface plate, or surface table. That is what you use an angle plate for. Now we have something else known as a V-block. So far we've been dealing with rectangular, triangular, irregular shaped workpieces. Now what if I have a workpiece that is cylindrical in nature, and spherical? How will I be able to mark it, to draw lines or arcs? I use a V-block. As you can see, this V-block has ni V tu, ni kitu ambayo imechongwa ikikuwa V. And this angle usually differs. Yeah? kulingana na the type of workpiece that you want to hold. Yeah. So these V blocks, you'll put your cylindrical workpiece in there, and then you'll use this. This is a clamp, a U clamp. Yeah. So this usually come as a pair. Yeah. V block and the clamp zinakuja as a pair so that you can get the correct size. Yeah. So unaweka your cylindrical workpiece over there ama spherical in nature kama hii pipe ambayo tunaona hapa, kisha una clamp. You tighten this screw and clamp that workpiece so that you're able to draw markings. You can be able to mark the workpiece. Now they're usually smaller ones kama hizi that are usually made from hardened steel, but there are those that are as large as me and even larger than we are. Kuna V blocks that are very big. Those are usually made from cast iron. Now the faces of these V blocks are usually machined to a high degree of accuracy or flatness. They are very flat. They are square and they're parallel, zimechongwa such that they have a high degree of flatness, parallelism and squareness. And this angle here, this V, is central with regards to these edges. Hii edge na hii edge, utapata hii V iko katikati yake. Sawa sawa?
Yes.
Now, another tool that we use for marking out is an engineer square. And this will be a very important tool. And I think we saw it when we were talking about the last class we had. When we are making threads, especially tapping the internal threads, ulikuwa unaona katika ile video, akishafanya process yake anachukua this engineer square, anaiweka just next to the drill, ama to that tap, to ensure that this tap is 90 degrees. Iko 90 degrees, usikuwa unatoboa shimo na shimo the angle that unatoboa shimo is not 90. Now, we use this engineer square when setting the workpiece square to the reference table. What do I mean by this? Kama sahi, katika hii diagram ambayo tunaona sahi, if I want to draw a line and I want it to be square, I want it to be perfectly straight. Nisichore a line alafu ikaenda hivi, ikaenda combo. I want it to be straight. What I'll do is I'll take this engineer square, place this stock, this is usually known as a stock, and we have a blade. I will place this stock onto the datum, ama the surface that I've said that I'll make my dimensions, ama I'll be taking my reference from, and this, let's say this is our datum. Kisha I'll be able to draw my lines straight, because above this will be 90 degrees to the reference edge. Now this engineer's blade is usually made from hardened steel, and this blade usually has a high degree of accuracy in straightness, parallelism and squareness, as we have seen in the other previous instruments tumekuwa tukiongelelea. Hii blade ambayo imechongwa hapo is very straight. You cannot make mistakes unless sasa imeharibika na iko na madent. But we use it to check for the squareness of our workpieces. We use it to ensure that if you are drilling, for example, the drill is at a right angle, ama iko straight. Are we together? Tuko pamoja?
Yes.
We test the squareness and we are able to draw lines that are perpendicular from a given edge. This being our datum, then we can be able to draw lines that are 90 degrees to each other. Ukienda kujaribu kuchora na ile rula ya kawaida, then you might make a mistake. Kwa mfano mkono ikateleza na line yako ikatokea at an angle. So we use this for making sure that our lines are perpendicular to a certain edge. Now we have a very important tool known as a combination tool. This is usually a steel rule, ni ruler, a steel rule that has 3 heads. Kuna hii head, kuna hii head, na kuna hii head. Now the first head is usually, this head ya katikati is known as the protractor head. We use this if you want to draw lines at an angle on the workpiece. Kwa hivyo nitakuja hapa niangalia which angle I want. Labda hapa ni 40 degrees. Then I can put this on the what? Kwa mfano, this is where I'll put my workpiece. I'll place it on this edge. Once I place it on this edge, then I can use this ruler to draw the line that I want, and it will be at an angle to my reference edge. When you're scribing lines at an angle on the workpiece, then we'll use this protractor head. Now, there's this head upper. Oops, I'm sorry. Kuna hii kichwa ambayo iko hapa. This one, this is known as a square head. It is the same thing as we use it with the same way we use an engineer square ile ambayo tumeona previously, but the ruler is adjustable. This ruler is adjustable. These heads can move. Zinaweza songa within this ruler. They have slots. They have slots in them so that you can be able to move them. So this is adjustable. So meaning that the measurements that you get are not as accurate. So that's why we have a spirit level inside here to help us to make sure that the measurements, some of the lines that we are scribing are perpendicular. They're perpendicular upper. Then you also have this, which is usually at 45 degrees. Kuna hii 45 degrees na kuna hii 90 degrees. So I can be able to draw a line that is 90 degrees to the reference surface, and I can also be able to draw a line that is 45 degrees to the reference surface. Yeah, we use this spirit level is there to help us make sure that the lines we're drawing are accurate. Because this head is movable, it is not fixed on this ruler. So the element of it moving introduces inaccuracies. We have this other head here hapa ya tatu, which is known as a center head. Now we use this center head to be able to establish the center lines of circular workpieces. Ni wapi katikati. So I will place a cylindrical workpiece over there, then I will be able to see the center line, the center of that workpiece. Mahali center line, I can be able to mark the center line of that workpiece, which is if it is cylindrical in nature, or if it is a round bar. So that is what we call a combination set. It incorporates the uses of an engineer square, a protractor, and a spirit level. Now we have a scriber. Now this is what we usually use to draw the lines on that metal workpiece. And sana when I say workpiece, I'm referring to metal. Unaonanga katika in masonry watu wako na chokaa, in woodworking people have pencils, but in metals we use a scriber. Now this is usually a piece of hardened steel that has a sharp edge. Steel, hardened steel that has a sharp edge. Now these are the two most common that you'll find in the industry. This is a pocket. This is a pocket scriber, and this is what we usually use mostly. This is the most common, the second one. Now this, the second one is the most common because it has this curved edge. We use this curved edge if you want to scribe lines that are not easily accessible. Kwa mfano I have a workpiece and iko na slots ama iko na shimo. I'm sorry. It has slots and I want to, for example, make I want to draw something, I want to scribe something inside that slot. Then this curved edge can be able to enter and scribe those surfaces vizuri. Are we together?
Yes.
We use this curved edge to scribe places that the straight end cannot reach. Now, a surface gauge. Now, if you look at this surface gauge, sana it is usually a vernier caliper, a scale that is vertical in nature, and a scriber that has been incorporated into that scale. Now we use this when we want to make markings. We want to make markings that is on our workpiece that is parallel to the reference surface. Let's say this is a reference surface na workpiece yetu iko mahali juu. The best example I can use is, for example, a lathe machine. Let me use that example of a lathe machine. Now, if you look at, let's say this is my lathe machine over here, and we've already looked at them in video, so I'm sure we all have an idea what a lathe machine is. Sindio? Tushaziongelea na tuna idea of what a lathe machine is. Now, if this is my lathe machine and this is my workpiece, when I attach my workpiece on my lathe machine, and for example, my workpiece is, let's say 10 centimeters, or let's say 20 centimeters, nimeiweka kwa lathe machine and I clamp, na nataka kufanya marking so that I want to reduce this from 20 centimeters to, let's say 15 centimeters. Siwezi ena nikachukua my scriber nikachora. It will be inaccurate. I won't just take my scriber and draw. It will be inaccurate. So what I'll do is I will take that workpiece, measure that 15 centimeters mpaka mahali nataka kukata. Then I will take that surface gauge, hiyo surface gauge ambayo natumia, kisha naeka next to the workpiece. Then that scriber nitaiekelea on top of my workpiece. Then I will rotate that workpiece. Okay? So if this is my scriber, this is the arm of that surface gauge, and this is the scriber. So nikizungusha my workpiece, then it will be making a marking on my workpiece, a regular marking ambayo haitakuwa inacheza if I had kama vile ningechora na mkono. So if I'm making a measurement that is parallel to the reference surface, then I will use a surface gauge. Now this height is adjustable. I can change this height kulingana na how high the workpiece is. So okay.
Yeah.
Now divider. A divider tu ni kama ile ambayo utapatanga kwa set. There is no difference. Now what do we use dividers for? Divider, we use it when you want to transfer measurements from, for example, niko na ruler and I want to transfer 10 centimeters from the ruler to my workpiece. I will take a divider, nipime 10 centimeters kwa ruler, and then I will take that 10 centimeters ambayo nimepima and draw, or I will inscribe it on my workpiece. So I can be able to transfer measurements from my ruler or my scale to the workpiece. I can also be able to measure two distances between 2 points. For example, I want to measure my workpiece. Workpiece yangu na sina ruler, ama niko na divider. I'll just take my divider, niipanue, put it at the two respective places that I want to measure, and then transfer that to the scale, and then I can be able to read what that distance between those 2 points is. I can also use a divider to draw circles and arcs on the workpiece. Vile tunatumianga tu divider katika math, ama wherever we use, ama engineering drawing, the same way we use it in the workpiece. So I'll go take my divider, nipanue, nipime, let's say 5 centimeters, and then I'll one leg nitaifinyilia at a datum, and then I can be able to draw an arc or a circle around that point. Now, we have different types of constructions of dividers. Kuna ile ambayo haina kuna ile ambayo inakuanga na spring hapa katikati. There's a return spring here, so that when you open it inajirudisha. We have those that do not have. Ni kitu tu unapanua na inapanuka, and then ukitaka kurudisha unafunga tu kama ile ya set. Now we have this point. This is known as the fulcrum, or the pivot. This is the point that allows it to open up and close, mahali ambapo those two legs of the divider have been joined. Now there is a limit to which I can be able to use a divider. Sana sana the maximum is 150 millimeters. That is the farthest I can draw the diameter of a circle or an arc. Now if I want to draw beyond that, what I use is a trammel. Now a trammel is essentially uko na a scale in terms of a beam. Kuna scale imechorwa kwa beam. It might be metallic, it might be metallic, inaweza kuwa ni mbao. These legs, we have two legs. Kama kwa mfano kama hii ni watu wa mbao. I might have a pencil. One leg is a pencil. A pencil is attached to it and one of it is fixed. Now what do? I will take this movable leg, nisongeshe to the distance that I want to measure. Let's say I want to draw a circle that is 400 millimeters in diameter. Kwa hivyo nitakuja hapo nipime a radius of 200 millimeters. Then I can be able, with this point fixed, then I can be able to draw a circle around my workpiece. If I want to do that on a metallic workpiece, we have these two legs. This naitoa, I unscrew, naisongesha mpaka mahali nataka ifike, I lock it, and then I lock this other one, then I can be able to draw a circle on my workpiece using these two hardened steel points. So we use a trammel to be able to make circles or arcs that are larger in size, kwa sababu there's a limitation to which unaweza panua these dividers. The maximum sana inakuanga 150. The maximum diameter of a circle you can draw using a divider is usually around 150 millimeters. Now we have a vernier height scale, and I want to talk about vernier scales because I've sent a video in the Google Classroom. I want you to go through that video very carefully so that you can be able to understand how a vernier scale is used. Because when you look at this, for example, this instrument, we have this scale here on the vertical stand, and that is known as the main scale. And then we have this smaller scale, and this is known as the vernier scale. Now the vernier scale is usually movable. In this case, if I want to measure something, let's say I want to measure something 15.23 millimeters. I will measure 15 centimeters on this main scale, and then I can be able to measure 0.23 millimeters using the vernier scale. Now go through that video so that you can be able to see how we read vernier scales. Because the vernier scale will be the same in this vernier height scale, it will be the same in the vernier scale ile ambayo tunatumia to read measurements and so on and so forth. So learn how to read vernier scales. Now this is usually used, remember we had talked about this surface gauge, and it is inaccurate kwa sababu if you don't tighten this scraper vizuri itacheza when you're marking. For example, vile nilikuwa nimesema ukiekelea next to a lathe machine and you uzungushe that workpiece, uzungushe the workpiece while you're touching, while this scraper is touching the workpiece, utapata kama hii kitu haiko locked, and this base zingine there are some that are clamped using a clamp, or there are some whose base is magnetic in nature. Hii base ikisonga kidogo hii itacheza alafu itoke. So if I want to make more accurate markings, then I can use a vernier height gauge, because I can this vernier scale increases my accuracy. It increases kwa sababu now I can be able to measure in terms of millimeters. Now we use a chisel. There's a chisel that is usually attached to this vernier scale. So ikisonga, then I can be able to mark kulingana na this scale. So I'll send a video of this vernier scale height gauge so that you can be able to see how it works. But we use it sana instead of using a surface gauge if you want to have more accurate readings. Now we have a precision steel rule. Essentially it's just a ruler that is made of steel. But the difference between this and the actual ruler that you use is the graduations. We have graduations in this steel rule that are in millimeters and half millimeters. This essentially increases our precision. The distance between the two indications inakuwa ndogo zaidi. So I can be able to read up to half a millimeter. We use this for general measurements. If I want to measure the length of an instrument or a workpiece, nitaenda tu nichukue hii ruler, the steel rule, nienda nipime, and I can be able to take those measurements. And so for general measurements, we have this. So it's essentially a stiff, straight steel metal that is machined on both sides, and on one side we have graduations that are marked in inches. There's this side that has inches, and then we have this side that has millimeters and centimeters. We have a center punch. Now, if I want to drill, confirm when you're looking at that previous class when we were talking about drilling and creating threads. Now, for me to be able to ascertain the place that I want to drill, the location that I want to drill, I use this center punch. It is for marking purposes. Itanionyesha mahali nitaweza the position where I drill. So how do I use it? I will go on my workpiece, and then I will nitachukua nyundo, then I will hold this place. This place is usually nulled. Iko na hizi imechonga chongo. It is roughed. Iko na rough edges so that you can be able to hold it by hand. Unaishikilia hapo, then you use a hammer to hit. That place that you hit will be the location where you can, ni hapo ndio umedecide uta drill. So it gives inakusaidia to mark the position of where you're going to drill. Now I can also use this center punch. Is usually used to permanently mark the center of circles and arcs. And you have to be very careful when you use these center punches, because sababu you will be unable to remove those marks once you, let's say you want to do finishing processes. It will be very difficult to remove them. Yeah. So you use them to mark the position of arcs and circles. And you also use it to show where you're going to start drilling. Now it is usually made from high carbon steel that is hardened, and the edge upper, it is chamfered. It is at an angle to prevent it from burning, because sababu you're hitting and there will be friction being produced. So to prevent this point from burning, it is roughened kidogo. That is what I mean by chamfered, and then it is at an angle. So that angle may change. The included angle may be 90 or 60, depending on the type of punch that you're using. This specifically is a center punch, but you have different types of punches. You have dot punches, you have prick punches, but they all do the same thing. Yeah, the only difference is the angle. We use them for marking the small marks, punch marks on the lines, on the layout lines. Remember, circles and arcs have center lines, so we use those to mark the position of the scribed lines by using the center punch. Are you together?
Yes.
Hapa ndio kama tunachora ana kama a circle, we use the center punch, unagonga na nyundo, and that will, let's say this is a workpiece. Nagonga na punch na toboa ka shimo kadogo, and then this will be where I'll put one leg of the divider, the trammel, then I'll be able to draw a circle or an arc. If I'm going to be making kama nataka kuchora laini across the workpiece, na nataka I want to permanently denote this line, then I can use a center punch na gonga along this line. Nagonga hapo. This will now be able to permanently show the position of this line on that workpiece. So that is what we use a center punch for. Now we have a clamp. We saw this when we are looking at the video making threads, external threads. Yeah. Now a clamp is usually used to secure your workpiece or your tool on the surface, on the working table. In this, for example, katika kama hii, this is a clamp. This is a U-clamp that is used in V-blocks. This is a clamp that will be used to secure this workpiece onto the angle plate. Now, the most common clamps that we use are this. We have the G clamp, kwa sababu it resembles a letter G, and we have the tool maker's clamp. Tool maker's clamp. These are the most types of clamp that you'll find being used in the workshop. So they are used to securely fix the workpiece on another piece of equipment. Now we have calipers. We have two types of calipers. We have the outside calipers and we have the inside calipers. The outside calipers are usually used to measure the dimensions of an outside piece of workpiece. For example, if I have a cylindrical, if I have a bar that is circular in nature, if I want to measure the diameter, the outside diameter, I will use the outside calipers. And as you can see, the shape of this easy meno, stick with the legs. The shape of these legs zimetokea nje. They are zimecurve ndani. Now I will put I will adjust these legs by open, kwa sababu there are some that have a spring and there are some that are ordinary. They don't have a spring, so I can just open them by increasing the angle between the legs. But there are those that have a spring. So what I'll do is I'll adjust these legs, open them up, then I'll place one leg on the outside of surface of this bar, and I will place the other leg on the surface of the other bar. Then I can be able to take this measurement that I get and read it on a scale. Nitachukua that measurement and I will place it on a ruler, then I can be able to know the outside diameter. Then we have inside calipers. As you can see, the outside shape, the legs are pointing to the outside. So we have the spring type and they have the ordinary type. Now what happens is we use these inside calipers to measure the internal dimensions. The internal dimensions of for example, I have a cylindrical bar ambayo iko na shimo. It is hollow in nature, and I want to measure the internal diameter. So I will take this one leg and I'll put it on the inside, and I'll take the other leg and I'll put it on the inside. And what I'll get is the internal diameter of this round object, this pipe. I can also be able to transfer the dimensions onto that internal diameter. For example, I want to mark something. I will take this, measure let's say I'll take the caliper, take it to a ruler, measure 5 centimeters, nipanue ikuwa ni 5 centimeters, then take it and mark it onto the internal surface of that pipe. Sawa. So we have outside calipers, we have inside calipers. For the outside, we use it to measure the outside diameter and the outside dimensions of a pipe or a round object. And the inside caliper, we use it to measure the internal dimensions of a round object. The shape of the teeth will help you the shape of these legs itakusaidia kujua which one is the inside and which one is the outside. For the outside, zinaangaliana. The legs, they are curved inside. Zinaangaliana. For the outside, for the inside, the legs are facing away from each other. Now we have something known as hermaphrodite calipers. We use these hermaphrodite calipers. For example, I have a workpiece that is rectangular in nature, and I want to draw a line that is parallel to my datum. Let's say this edge is my datum, and I want to draw a line that is parallel to that. So you'll see that one leg of this hermaphrodite caliper is straight and one leg is curved. So the straight leg is usually curved. Ikona a provision at the end such that I will place it upper. I will place it on the datum. Labda I want to draw a parallel line to the datum, maybe 5 centimeters. I want it to be 5 centimeters. So I will take this, measure 5 centimeters using a steel rule, Then I will use this straight leg and place it on the datum. When I place it on the datum, then I can move it along the datum, and this sharpened piece, the sharpened end, will draw a line that is parallel to this datum. Are you together? We use it to scribe lines that are parallel to straight edges. When you have a straight edge, you use the straight edge. The straight leg will be placed on the straight edge, and then it will be moved on the straight edge, and then a parallel line will be drawn to the straight edge. So if I want to 10 centimeters from the straight edge, nitaenda nipime 10 centimeters between my legs and place this straight leg on the straight edge, and the bent leg that has the sharp point will now be used to draw and scribe a line that is parallel to that straight edge. Kama tuko pamoja, please unmute and say that I'm present.
Present.
Okay. Now, what I want you to do, I learned the lesson for today, but there are two important tools that I haven't mentioned: the vernier caliper and the micrometer screw gauge. I want you to go read. Enda kwa YouTube, tafuta video, one vile inakaa, vile inafanya kazi. Go read and write notes on those two because they're very important. Unaweza letewa swali and you're drawn, you're given a picture and you're told to calculate the measurement that is shown on that picture.